Hello and welcome to another walkthrough video of IAL Edexcel AS Level Physics, and today we are going to do the walkthrough of May 2025 Unit 1 exam, which was conducted in May 2025. And I couldn't do that earlier on because I was very much busy with my students. So I have covered it in a very technical way, and I explain each and every question along with its concept, which is relevant for your upcoming exam as well. So please watch this. Please watch this walkthrough, and it will turn out to be very much helpful for your preparation for the final exam next week. Okay. So let's start. Question number one: a cube of volume V is placed in a liquid of density rho. The cube displaces a weight W of the liquid. Which of the following give the magnitude of the upthrust acting on the cube? Remember that the upthrust is always equal to the weight displaced by the object. Weight of liquid. Okay, weight of liquid displaced by object. So from here, you just write this, and from here, you just write this rho V and G because W is mg and density is m over v, so you just write m equals rho v, and you just put mass equals rho vg. Okay, and actually here the rho is the density of fluid. Okay, not the density of the object, remember. So in that way the option is going to be right away D. Question number two: a seesaw is a uniform beam that balances on a support. The beam can rotate around the top of the support. Two children of equal weight sit on a seesaw at equal distance from the support as shown. Since they are at equal distance, so this is the pivot. Okay, so its moment is going to be this way, and its moment is going to be this way. So this is going to be clockwise, this is going to be anti-clockwise. Since they have at equal distance, so anti-clockwise moment will be equals to the clockwise moment. And since they're not moving as well, so the sum of forces are also zero. So you can just write the sum of moments is zero and sum of forces to be zero. So the option is A because they're not moving around. The diagram shows ball of a mass m moving at speed v along a horizontal table. The ball leaves the table. The time taken between the ball leaving the table and landing on the floor is t. A second ball of mass 2m moves at speed 2v along the table. Which of the following gives the time taken between the second ball leaving the table? Okay, there is a first ball with mass m, okay, and it takes time t to reach the ground with speed v, okay. Now, okay, we have not mentioned about anything. So there is another ball of mass 2m, and it is also coming at a speed double than the previous one. Okay, they have mentioned about v. So now we need to know the time here. Since this is a free fall object, remember that for free fall object, you must write always the second. So S equals ut plus half at square. And since the body is starting from the rest, so your initial speed is 0 here. So you just put 0 here, and it will turn out to be halves, and the body is coming down. So your acceleration has to be replaced with the gravitational acceleration. From here, I am getting 2s over t square equals g. So if you see that the gravitational acceleration is not depending on the mass or the speed, it's just constant, it just depend on the height, which is same, and the time. So since the s height is not changing, right, and the gravity also not changing, so t must also not be changing. Okay, therefore you will just write the T is same as for mass m. Okay, so previously it was the mass m which was coming down in the time t. So the body with mass 2m will take the same time to reach the ground with the same gravitational acceleration. Therefore, the option is B. The forces acting on a person sitting on a chair are weight and normal contact forces. Which of the following gives a reason why these forces do not form a Newton's third law of motion pair? Okay. So remember that in order to be applicable for the Newton's third law of motion, so you need to remember these conditions. Conditions to apply Newton's third law. Firstly, there must be two bodies. Second is body 1 acts on body 2. That will be action. Okay. And then body 2 will do the reaction on body 1. So that will be reaction. So these forces, there are two forces, action and reaction. The two forces should be of same nature. Okay. Must be same nature. And finally, they are equal in magnitude and opposite in direction. Remember that. So same nature of forces means one, if one weight is normal, if one force is normal and the other one is weight, so they are not of same nature. Okay. So here you can see that one force is the normal contact and the other one is the weight. So they are not of the same nature of forces. Okay. And it is being fulfilled here, but since you can see that it is not an option here, so we need to look for another option, and you need to see each option one by one. So in here you can see that there is a chair and there is its weight acting down, and the normal force is also acting on the chair. Okay, so when two forces acting on the same object, then it means they are violating the second condition. Okay. And in the second condition, I mentioned that the first body must be applying force on the second body, and the second body must be applying force on the first body. But here, the normal is also acting on the chair, and the weight is also acting downward on the chair. So, therefore, they are acting on the same object. Therefore, it cannot be true. So, they have mentioned not. Therefore, this is the option. A wire is used to hang a picture from a hook on a wall. The wire exerts force T1 and T2 on the picture. The picture has weight W as shown. Which of the following describes the relationship between the forces when the picture is hanging on the wall? This is the keyword, hanging on the wall. When it is hanging on the wall means acceleration is 0. So when acceleration is 0, sum of force is 0. Okay. So this sign is actually sum of forces. So when the sum of force is 0, it means this whole force is a vector, this whole force is a vector, this whole force is a vector. You just need to add all these three forces and get to option B. Question number 6, an object has a constant non-zero acceleration. So that is the keyword, constant and non-zero acceleration. Which of the following displacement time graph could represent the motion of the object? A, B, C, and D. Okay. So I give you a hint. For example, if I throw a ball upward, okay, and then it comes down. While it's moving up, it has a gravitational acceleration, which is minus 9.8, and when it's coming down, it has a gravitational acceleration plus 9.8, correct? So in both ways, its acceleration is constant and non-zero, but just changing its sign, right? So therefore, it is only true when you throw an object upwards, it goes that way, it reaches its max height, okay? And this was the ground. And since displacement is a vector quantity and you are coming back to the ground, so when the ball is coming back to the ground, its displacement is again zero as it was before, okay? Because displacement is a vector quantity. Say it has traveled up till here plus 5. So when it is coming down, it's minus 5 because it's a vector quantity. So 5 minus 5 is 0. So again 0 here. Okay, therefore, this is the only option. The forces acting on a helicopter are shown. The helicopter is represented by the dot. Which of the following expressions give the magnitude of the resultant force? Okay, so there are three forces acting. Two are in opposite direction. Remember the rule. When you have three forces and two of them are in opposite in direction, so first of all, you need to subtract those two forces and get one force. So this will be 200 and 15,000 minus 14,500. So you will just left with 500. Okay. Now you need to add them according to head to tail rule, and you need to know that the head to tail rule says that you need to connect the head of the first vector with the tail of the second vector. So this is my second vector and this is my first vector. So I am connecting the head of first with tail of second. Okay. And when I do that for all the vectors, similarly, if I had three, so I will connect the tail of the third vector to the head of the second, and so on. So the result is always obtained when you connect. So result is always obtained when you connect the tail of first to the head of last. Okay. Tail of first to the head of last. To the head of last vector. And you can easily see that this is going to be a triangle, a right angle triangle. So for the right angle triangle, if this is my base, this is my perpendicular, this is going to be my hypotenuse. So hypotenuse square is actually perpendicular square plus base square. You just need to take the under root, and that will be just 500 square or 15,000 square minus 14,500 square plus 200 square. Okay. So instead, you can just write 15,000 minus 14,500. You need to remember that it is a whole square, not an individual square. Just like that, it is not an option, okay? Be careful. Plus, so the option is D. A box of weight W slides down a ramp. The ramp is at an angle theta to the horizontal. A force F acts on the box as shown. Which of the following is correct when the box moves at a constant speed? Another key word. You need to focus on the keywords if you want to be successful in this exam. Constant speed means acceleration is zero. When acceleration is zero, the sum of forces are also zero, okay? So when the sum of forces are zero, how can you manage to see how the sum of forces are zero? First of all, the weight is acting downwards, so the normal force is acting this way, correct? Then you need to divide the weight into its components, correct? So the component of the weight is going to be So this is theta and this is 90, correct? And if you see, because whatever thing that you have in here, it will come here. So for example, if here it is 25, you need to write here 25. So if it said theta, you have to write here theta. Now theta and 90 are on this side, so this is going to be my cos side. Wherever you have the wherever you have the theta and the 90, it represents always the cos side. So W cos theta, and the other one is actually W sine theta. And if you take a look that this N has been balanced with W cos theta, I mean these two forces have been cancelled out, and the F is going leftward while the W sine theta is going the rightward. So you can see that either you write W sine theta here, or either you keep the W sine theta below, as I have done. So it makes no difference. It will be all same. So this force and these two forces and these two forces are being cancelled with each other. Therefore, the option is going to be F equals W sine theta. Okay. The driver of a car applies the brakes. The frictional force F between the tires and the road is constant. So this force is constant. Remember. The average power dissipated is 50 kilowatt. So when you apply the brake, you see there is a heat generated and everything. So it means that the power has been wasted or dissipated or lost. The car moves a distance 13 meter in this much time. Which the following expression gives F in newtons? Okay. So first of all, you need to write the formula for the power. Power is equals W over time. W is work. Work is force times displacement over time. You have the power to be 50 equals. You need to write down the weight. You have the distance 13 meter and you have the time 2.3. So from here, 50 into 2.3 divided by 13. Since the power is in kilowatt, so you need to write force to be 50 times 10 raised to the power 3 times 2.3 divided by 13. So this is going to be the option A, right? Yeah. Yeah, is the answer. And मेरी रिकॉर्डिंग हो रही है मैं यहाँ ऊपर जाऊँ मैं हाँ?
हाँ नहीं ज्यादा स्लिप हो जाओगे वो अपने वहाँ जाओ ना पापा जा रही है
So, question number 10. A toy train of mass 3m is moving with a speed v. A toy track of mass m is moving with a speed 2v in the opposite direction as shown. The train and truck will line and move off together. Which of the following expressions give the new speed of the train and the truck? Very easy question. In law of conservation of momentum questions, first of all, without going into anything, without seeing anything, just write first of all the equation of conservation of momentum, which is m1 u1 equals plus m2 u2 equals m1 v1 plus m2 v2. Then look for the keywords. What is mentioned? Since they are moving in opposite directions and the momentum is a vector quantity, so if one momentum is going this way, the other momentum is going the opposite way, it has to be a negative one. Therefore, you are going to remove this plus from here and put a negative here. Okay, then after that, after the collision, they are move off together. This is another keyword. So when they are moved off together, it means it turned into one system. Okay, one with mass 3m, one is mass m. So it is now one system which is traveling at some speed. And when it is a one system, it has just one speed. Okay, so it means that you have to remove this m1, you have to remove this m2, and you just need to write 4m. Okay, also this is gone, so you just write 3mv plus mv, and from here you got to have 4mv, right? So from here you have m1 u1 minus m2 u2 equals 4mv. Okay, right. So since you can see that the speed u1 is v and u2 is also 2v, so you just need to put the value of u1 to be v, then m2 and the value of u2 to be 2v. So from here this is going to be the option, and when you open up the brackets, and since m1 is simply m 3m, apologies, and m2 is actually m, right? So 3mv minus 2mv equals 4mv, and they're actually asking for the new speed or the final speed. So from here 3mv minus 2mv is simply mv divided by 4m, correct? So that is your new speed. So m got cancelled with m, and from here you got to have this as your new speed. So you need to look for the answer, and the answer is A right away. Question number 11. A resultant force of 1400 Newton acts on a boat. The acceleration of the boat is 0.31 meter per second square. Calculate the weight of the boat. Oh, easy question. F equals ma, and 4800, m 0.31. Okay, and from here you got to have 4800 divided by 0.31, and that weight is going to be w into m into g. So 4800 divided by 0.31 is your mass, and the value of g is 9.8. So w is going to be 151,741 newtons, I believe. But wait, if you write the answer that this is my answer, you're just going to get 2 by 3 in this question. Why? Because in the data of your question, you just have two significant figures. So your answer should also have only two significant figures. So you have to not write this in the exam. Rather, you have to write 150,000 newtons. Okay. And in this, you will have two significant figures, and that is the only way you will get 3 by 3 in this question. Okay, so that is the trick where Edexcel reduce the marks of so many students. They always penalize those students which do not consider the figures rules in writing the answers. Let me show you the mark scheme. See, in the calculation, they are like writing like 152,000. So in 152,000, you have three significant figures, but they are saying 1 mark is for 150,000, not for 152,000. You understand that? So it is something that you need to be careful with. A person rides a bicycle along the path shown. At the end of the path, the magnitude of the displacement from the start is less than the distance traveled by the person. Describe why the displacement is less than the distance traveled by the person. It's just obvious that the displacement is always straight line like this. So we just need to mention displacement is the shortest distance between 2 points, whereas distance is total path traveled between 2 points. Okay, so this is actually straight line and a vector. It is not necessarily to be straight line. Sometimes it can be straight line as well, not necessarily to be straight line. And it is scalar. The velocity time graph for the part of the bicycle ride is shown. Determine the maximum acceleration. So acceleration is actually final velocity minus initial velocity over time. Okay, so it means this is your rise and this is your run. So the gradient of this graph is actually acceleration, right? So if velocity is high, it means the gradient is high too. So you need to see which part of the graph is actually having the steepest area. And you can easily see that this is the steepest area. Steepest means which is having the highest incline. This is not steepest. This is not steepest. So this is the steepest, and therefore it will have the um, highest acceleration. And for this part, you need to see this one and this one. And just need to write down the answer like it's going to be 1.6, 1.1, 1.2, 1.4, 1.6. Yeah, 1.6. And this is going to be 5 minus 0. So acceleration is 5. Oh, sorry, here it is 1.8. So 5 minus 1.8 divided by 16. And here it is 4, I believe. So 16 minus 4. From here is going to be 0.267 meter per second. Since you don't have any data given here, so you have the freedom to write any number of significant figures in your answer. And it's, by the way, acceptable. So you can just round it off to 0.27 meter per second, just two significant figures. In a game of basketball, points are scored by throwing a ball so that it falls through a hoop. The rules state that the distance d between the hoop and the floor should be 3. A basketball player throws the ball so that it falls through the hoop as shown. The ball was thrown from a height of 1.7 meter above the floor. The initial vertical component of the velocity of the ball was 5.1 meter per second. As the ball entered the hoop, the vertical component of the velocity of the ball was 2.1 meter per second. Okay. Deduce whether D was 3. It is a typical projectile question, so that is your reference point. Remember, first of all, you are throwing off the object, so this is your launching point. And this is the point where the object is falling, okay? Right. So here the body is flying like that, so it is V, but they are talking about the vertical component of the speed. So the vertical component of C here, sorry, not V, is U sin theta, and this is U cos theta, okay, at 90 degrees to each other. And here they have mentioned the vertical component of the speed. So speed here will be like this, V, and this will be its V cos theta horizontal component, and the vertical component here is V sin theta, okay, right. And this height is actually 1.7 meter already. So all you need to do is just to measure the height from here to here. So you need to see when the ball is coming to the hoop, at what distance it is from the launching point. So usually in the projectile questions, you have three kind of situations. When the ball launching point and falling point is actually same. When the ball's launching point is low and the falling point is high. And when the ball's launching point is high and the falling point is low. Okay, these three kind of situations. So this one is actually this one. And in this second situation, when you find out the distance is actually always positive. So for example, if it is showing 1.5 meter, if I calculate and an answer is going to be plus 1.5, it means when the ball will fall, it will be actually at 1.5 meter from the launching point. And for this third case, actually distance always comes out to be negative. So for example, if I had this kind of situation, my displacement will always be negative. And if I say that the displacement is coming out to be minus 1.5, it means that from the launching point, which is this launching point, the ball is at 1.5 meter below the launching point. Okay, that is actually the meaning of negative displacement and the positive displacement. So now you need to calculate the distance, vertical displacement, and it must be positive because it is from the second case. And in the first case, the displacement is actually same as initial point because you are having the same points. So in these cases, you have some different scenario which will be discussed later on when we have that kind of question. But for now we have second scenario, and for the second scenario I know that the displacement has to be positive. Okay, so I am going to write SUVAT third vy square minus uy square. Why I'm talking about vy, not v? Because I have to apply SUVAT to the vertical part of this projectile. And for the vertical part, I need the vertical component of the velocity, not the horizontal component of the velocity. And while I am having the vertical component of the velocity and I'm finding the vertical displacement, I should take acceleration as negative because initially the body is moving up and later on it's coming down. So later on it's coming down, so its acceleration should be positive g, but initially it's negative g. And while solving the projectile questions, you have to remember that you always refer to the initial data, not the final data. Whatever is happening at the end, you don't need to care about that. You need to see what is happening or what data do you have initially. Initially the body is moving up or not. If it's moving up, you need to write your g as negative. Therefore, the final speed that you have is 2.1. So you just write 2.1 square minus uy is 5.1 square. And you just need to calculate it for the displacement. Okay. And when you calculate for the displacement, you have minus 2 into 9.8, and it is going to be 0.225 meters, which you can round off to 0.23 because your data has only two significant figures. So your answer should be rounded off to two significant figures. Otherwise, you're going to lose 1 mark in this question as well. Please be careful with that. So now it means that the 0.23 is the distance at which the ball will be presented from the launch point. Okay. So from the launch point, when it is going to fall, it will be at 0.23 meters. So now what is the total height of this hoop? It was 3 meters. Now you need to see, is your height equal to, is the height of the basketball equal to 3 meters? No, it's not. So you will just write height of the ball 1.7 plus 0.23. So it is simply going to be, uh, I think I did a mistake. It's not 0.23. It is something different. My apologies. I think it's 1.1. Yeah. Okay. So you just need to say that 2.8 meters. And here it is also 1.8 meters. Sorry, 1.1 meters. Okay. So you were actually deducing that whether D was 3 meter. So you need to say no, it is not. Rather, it is. It means the ball is reaching the hoop at a height 2.8 meters. So it is actually not present at 3 meters. 14. The brakes in the car reduce the kinetic energy of the car. In an electric car, some of this energy is transferred to the battery in the car. An electric car of mass 1800 kg moves at a speed of 14 meters per second up a hill, as shown. The driver applies the brakes to bring the car to a stop. During braking, the vertical displacement of the car is 0.76 meter and the energy stored in the battery increases by 45 kilojoules. Calculate the efficiency of using the brakes to charge the battery. This is the keyword, using the brakes to charge the battery. Using the brakes to charge the battery. So first of all, you need to know that when brakes are applied, initially you have simply kinetic energy. Okay, a simple kinetic energy, and you're moving up. So your kinetic energy will be changing into potential energy, gravitational potential energy. Okay, and then some of the energy is going to be stored in the brakes to charge. Energy used by braking system to charge the battery. Okay, so this equation is something that you have to make yourself in the exam, because it is written calculate the efficiency of the brakes to charge the battery. So it means the energy has to be shifted in the battery through the available energy, because law of conservation of energy says you cannot create energy, you just transfer energy from one form to another form. So if initially body is moving and it is having kinetic energy and you are running on an incline towards some height, it means your kinetic energy is going to be reduced, and when your kinetic energy is going to be reduced, it will be converted back into gravitational potential energy and the energy used in the charging of the car. So first of all, you just calculate the kinetic energy of the car, which is half m. M is 1800 and v, which is 14 square. Okay, then they're saying battery is using this much of the energy. Okay, so what will be the gravitational potential energy? Hmm? And why we are calculating it? Actually, this is the amount of energy that we have to subtract from the available energy because it is gone in the form of gravitational potential energy. So it will not be available to the battery system to get charged. So this is actually 45,000 joules given. So from here, I got the gravitational potential energy as 13406.4 joules. Okay, I'm just subtracting these and getting this answer. So that is the energy gone out of the total available energy. And when I calculate this, this is the total available energy. And it is going to be 176,400. Okay, this is the total energy. Now they're asking calculate the efficiency of using the bricks to charge the battery. So percentage efficiency for the braking system. So you will just write energy of braking system. All right. Divided by total available energy. And how much the energy available to you? Energy of the braking system was 45,000. The total available energy to you was 176,400 initially, but GPE has taken 13406.4 joules out of it. Okay, so you just say subtract that. So this is the percentage efficiency. And when I calculate that multiplying 200, it is going to be 0.27 point something 8%. So you have to round it off to 28%. Okay. A builder uses bricks to build a wall. As the wall gets taller, the force on a brick at the bottom of the wall increases. A force compression graph for this brick is shown. Okay. Determine the increase in the elastic strain energy in the brick as the force increases from 85 Newton to 140 Newtons. So this is 150 Newtons. Okay. So they're saying the force has been increased from 85 to 140. So 85 is where 60, 70. This is 80, this is 90. This is somewhere in the modality 5, okay? And I need to take this line in the end here, okay? And it is falling up to is 50, 60, 70, 80, 90. So it's 60. Okay. And they have mentioned 140. So 140 is this point. So I'll take this line up till here. and we'll come back all the way down here. So it will be somewhere around 60, 70, 80, 90, 96, I believe. Right? I think it is going to be 96 something. Okay. So it's nanometers. You need to remember, okay? So now the strain energy is going to be So you just declare the first point as A and the second point as B, and you just need to calculate the elastic strain energy for point A, which is given here. The elastic strain energy at A is half F into X. The value for the F at A is 140, and the X compression at A is 96 into 10 to the power minus 9 because it's nanometers. So you just multiply these two and get the elastic strain energy at A. Then similarly, you have to consider elastic strain energy at B, and the value for the force at B is 85, and the extension or compression is 60 nanometers. So just multiply and get the answer. Finally, you just need to subtract the two to get the change in the elastic energy. So 6.7 into 10 raised to the power minus 6, it's minus 6, minus 2.5 into 10 raised to the power minus 6. So 6.7 minus 2.5 is going to be 4.2 into 10 raised to the power minus 6 joule. This is the change that you will have in the elastic strain energy in the brick as the force increases. Okay. Remember, in the kind of material questions like this one, you may get confused with the word compression. Sometimes they refer to the thing extension, and sometimes they refer to the word compression. So, for example, I have a spring or I have an object, and when I say compression and it has length, for example, 1 meter, and apply a force for extension and say that because of this force, its length turned out to be 1.1. So I will say that the final length is actually L plus delta L because there is an extension in the object of 0.1 meter, right? But when I say compression, so for compression, I have the force in opposite direction. So its length is not going to be increased, rather it is going to be decreased. So in that case, you should write length minus delta L, okay? Because 1 minus 0.1 is actually 0.9. So that is something you need to be very much careful with, whether it is mentioned about compression or expression or extension. Okay. The brick undergoes elastic deformation. State what is meant by the elastic deformation. Elastic deformation means an object can uh, there is something wrong with my pen. Okay, an object restores to its original shape, you can say, or position, you can say, when the external force is removed. Sorry, not reduced, removed. Question number 16. A student used a falling ball method to determine the viscosity of the vegetable oil. He measured the diameter of a ball bearing. He dropped the ball bearing into the measuring cylinder containing vegetable oil as shown. Okay. The ball bearing reached terminal velocity. The student then measured the time taken for the ball bearing to fall 20 centimeter. So it means when the ball is moving at terminal velocity, the speed is constant. Okay. So when the speed is constant, you can do distance over time because this is true for constant speed. So The time taken is something that you need to measure. Okay, give one other measurement needed to determine the viscosity of the oil. So you have to write, first of all, what is viscosity? Viscosity is 6 pi r eta v. Okay, so if you want to write, if you want to find out the viscosity, you have multiple options available. 6 pi r v, and in this f, you can write f equals mg over 6 pi r and v, right? So what do you think to write? Do you think radius is an option to find out the viscosity? Well, I believe it is not an option because it just explains how quickly or how lately the body will obtain the terminal velocity. Because if the object is small, it will have less drag on it, so it will take some time to get to reach to the terminal velocity. But if an object is large, for example this, so if an object is large, it means large drag is acting on it. And when the large drag is acting on it, it means it will reach the terminal velocity quickly. So the radius is actually the measure of the drag force, not the viscosity exclusively. So the viscosity is coming out from mass exclusively, okay? Or weight, you can say. So you need to write mass or weight of the ball. The diameter of the ball bearing was 1.24 millimeter. The time taken to fall 20 centimeter was 1.3. So why they're mentioning distance and time? Because they have explained already that the ball is traveling at terminal speed. So you can easily calculate the terminal velocity by using distance and time. The student calculated the value 5.6 newtons per minus 5 Newton for the viscous drag. So this is the drag force D on the ball bearing. Calculate the viscosity of the oil. So simple to write. Diameter is 1.24 into 10 raised to the power minus 3. So its radius is going to be 0.62 into 10 raised to the power minus 3 meters. Time is 1.3 seconds. It is falling through the distance of 0.2 meters. And they're just asking for the viscosity, nothing else. You don't need to use this equation of thrust plus weight equals drag. No, you don't need to use that because this is the equation for the net forces acting on the body. Okay, but here they are exclusively writing just calculate the viscosity. So for the viscosity, you just need drag, nothing else. Okay, therefore you're just going to write 6 pi r eta v. You don't have v, but you have distance and time. So for the distance and time, you're going to write oh, I have not mentioned the weight, which is 5.6 into 10 raised to the power minus 5 Newton as well. So you just put in the values. 5.6 into 10 raised to the power minus 5 equals 6 pi. R is 0.62 into 10 raised to the power minus 3. You need to write now the viscosity and finally the velocity as distance over time. So distance is 0.2 divided by, I'm replacing the speed as distance over time, so it is 1.3. From here, the viscosity is turning out to be 3.1 into 10 raised to the power minus 2. Okay. Now you can see that here you have two significant figures and here you have three significant figures. So I believe you have the option to write whether in 2 significant figures or 3 significant figures, but mark scheme always prefer to write answer in the least significant figures. Therefore, they have mentioned the answer in the least significant figures as 0.031. Okay. Yeah, 0.031. Oh, no, yeah, 0.031. So it's 0.031 or 3.1 into 10 raised to the power minus 2. Okay, so it's actually something similar, Pascal seconds. Yeah. Okay. See, the student repeated the experiment. He used the same oil at low temperature. Explain how using oil at low temperature affects the time taken for the ball bearing to fall 20 centimeter. So again, you need to say when T increases, the molecules in the fluid or liquid, because fluid means liquid and gas together. So fluid or liquid here, which is oil, will move away from each other because they will be absorbing energy from the high temperature, right? When you increase the temperature, it means you're providing the energy which is absorbed by the molecules. So they are moving away from each other. So when they're moving away from each other, their density is actually decreasing. So when density is decreasing, for example, previously these number of particles were here, but now when you rise the temperature, only 2 particles are below the ball bearing, which is dropping off through the liquid. So there is a less drag here. Okay. So less drag means more speed, right? More speed means more distance. More distance means less time it will take to cover. Okay. So you would just write density decrease as a result. Write these numbers in points. So as a result, you say the object or the ball bearing moves faster. Because it is traveling faster, it will take less time. It will take less time to cover 0.2 meter distance. Okay. A violin is a musical instrument that has 4 strings as shown. A force extension graph for a sample of one of the string is shown below. The table shows a stiffness for the sample of 3 of the strings on the violin. Each sample was the same original length as the sample used to obtain the graph. Okay, so you have 3 strings X, Y, Z, and they have calculated the stiffness for the 3 and tabulated that. Deduce which string was used to obtain the force extension graph. Just you need to find the stiffness. Stiffness means K means spring constant, and the spring constant is actually F over delta X. So simplify now the gradient. So I am talking about the gradient as 40. I think this point is better. Yeah, so it's 40 minus 0 over 15 into 10 raised to the power minus 3 minus 0. So the K spring constant is going to be 2667 Newton per meter. So let's check. It's going to be string Y. Yeah. Okay, the fourth string on the violin has original length of 0.75 meters. When the tension applied to the string is 36 Newton, the new length of the string is 0.752 meters. Okay, the radius of the string is 0.85 into 10 to the power minus 5. Determine the Young modulus of the material used to make the string. Very easy question. All you need to do just to write what was your original length. It was 750 meter. What was your extension? Your extension is new length minus original length. It is going to be, just subtract the 2. Okay, 0.02 002. Okay, 0.002 meters. This is the extension. The radius of the string is 0.85 into 10 raised to the power minus 3 meters. And the force applied is 36 newtons. And the Young modulus is now stress over strain. The stress is force over area. The strain is change in length over original length. So from here, FL over A del del, just simplifying it and putting in the values, is 36 into length is 0.75 divided by area. You don't have area, so you just write pi r square. And the change in length is 0.002. Okay, and that's it. Just put in the values for the radius. It is 0.85 into 10 raised to the power minus 3 and 0.002. And the answer is going to be 5.96 into 10 raised to the power 9. So I'm just writing it with the mark scheme. I'm not calculating it. So 5.96 into 10 raised to the power 9 pascals. And since in the data you have 2 and 3 significant figures again, and in the mark scheme you can easily see that they have rounded off to 1, and in the 1 they are mentioned 3. So whether you write 5.96 or 6.0 into 10 raised to the power pascals. Since strain has no unit, so the unit for the Young modulus is the same as the unit for the stress. Okay. So question number 18. A Newton's cradle have 5 identical steel spheres A, B, C, D, and E. Each sphere hangs on a string from a frame as shown. Each sphere has radius of 7 into 10 raised to the power minus 3. Calculate the mass of one sphere. So it's very simple. Density is, oh, there's something wrong with my pen. Okay. Please hold on. I think there's something wrong with my pen. Yeah, that's fine, I think. Okay. So density is mass over volume. So mass is rho into volume. And they're just saying one sphere. So density is 7.8 into 10 raised to the power 3. And the volume of the sphere is 4 over 3 pi into r cube, which is 7 into 10 raised to the power minus 3 cube. So it is about 1.12 into 10 raised to the power minus 2 kg. And if you can see, the number of significant figures is just 1 or 2. So maybe you can write just 1.1 into 10 raised to the power minus 2 kg. Okay, so let's check what's the mark scheme. Yes, if you see, it's down there, but 1 mark is for this. A student pulls a sphere A, so the string is at an angle of 38 to the vertical as shown. The student then releases sphere A. Determine the initial acceleration of a sphere when released. Very easy question. So you know that when the sphere is hanging like that, there is a tension in the string like this, okay? So if this is a wire going to the center vertical line, we call it the line through the mean position. Okay. So if this is the tension, I can divide the tension into 2 components. One is this component, right? And one is this component, correct? So if you see, this is theta and 90. So this side is having 38 and 90. So it will be my cos. It will be t cos theta. And this will definitely going to be my t sine theta. And they have mentioned the direction of acceleration. So since the object is moving this way, it means this force t sine theta is actually responsible for the acceleration in the object. So you will just write F equals ma. There must be a force. And this t cos theta is actually being balanced with the weight. Weight is acting downward and t cos theta is moving this way upward. So you will just write t cos theta equals W. Just for your understanding that these two forces have been cancelled with each other. And the only thing that is left here is t sine theta, which is actually producing the acceleration in the object. So you would just write this. And the mass of the object is known, 1.1 into 10 to the power minus 2. So you will just write ma over t sine theta, correct? Then tension is actually mg sine theta. Okay, mg sine theta, m got cancelled with m. Oh, I did something wrong. Apologies. Apologies. T equals mg sine theta equals this. It got cancelled. So acceleration is simply g sine theta. And it is 9.8 sine 38 it was, yeah. Um, so the answer is, or you can round it off to 6 meter per second square. Diagram 1 shows the position of the spheres when sphere A is released. After being released, sphere A collides with sphere B and comes to rest. Sphere B, C, D remains at rest. Sphere E moves away from the sphere D. Okay. Diagram 2 shows the position of the spheres when sphere E reaches to the highest point. I have this actually, by the way, on my table. My brother-in-law from USA gifted this as a toy, and I play that around with me. Like in free time, I just play with this, and actually it happened exactly like it is described in the question. So diagram 2 shows the position of the spheres when sphere E reaches the highest point. Describe the changes in the energy and the momentum of the spheres A and E from the time sphere A is released until sphere E reaches its highest point. Ignore the effects of air resistance, so no loss of the energy. Remember that, okay? Initially, at this point, you are at the highest point, so your gravitational potential energy is max, and you are not moving. I mean, the bulb is not moving, so kinetic energy is zero because kinetic energy is half mv square. Is half mv square, and since v is zero, so when you put zero, the kinetic energy is zero itself. Okay, so therefore you say the kinetic energy is zero as well. Okay. So first of all, let's start writing for this kind of question, like a 6 marker. One thing that you have to be very much careful is your answer should not be randomly explained or randomly written. It must follow a sequence. So for example, you have to start from E. If you start from E and come back to A, you will get 0 marks in this question. So you have to follow the sequence of things that are happening. So you need to explain one by one. So for example, at point A, your GPE is started to be converted into KE. So you have to write the first one as at A, GPE is max, KE is 0. Okay, since at rest. Okay, because Bob is at rest. Bob Bob is coming down towards B, and what is happening? GPE is converting into KE. Okay, because now our body is moving and having some velocity which was 0 earlier. Then at B, KE is max. Okay, and momentum is also max. And momentum was here 0, also because velocity was 0. GP is converting into KE and momentum is increasing. You can write this as well. Momentum is increasing because the speed is increasing as we increasing. Then at B, K is max and momentum is also max. Then at 4, you have to say the kinetic energy and momentum is transferred from A to E through B, C, and D. Okay. So for E, as it moves to its highest point, its GPE becomes maximum as it was for A. Okay. Since there is no loss, considering no loss of energy. And KE and momentum becomes 0. So initially you saw that the momentum was 0 for A, and for E, the momentum is also 0. So this point explains that, and all this process momentum and kinetic energy remain constant. This is something very much important. As you have seen for A and E, the momentum was 0 and the kinetic energy was 0 as well. A student stores her bicycle on a rack. The bicycle rests on a rail that can rotate about a pivot. Okay, so this is the pivot. Okay, to take the bicycle off the track, the student use handle to lower one end of the rail to the ground. A piston applies a force to the rail as the rail is lowered to the ground. The diagram shows the bicycle on the track before and after the rail has been lowered to the ground. When the rail is in equilibrium, the principle of moments applies. State what is meant by principle of moments. So clockwise moment is equal to anti-clockwise moment, or sum of moments on a body in equilibrium must be written in equilibrium to be 0. Okay. After taking the bicycle off the rack, the student lifts the rail back to its original position. The uniform rail has a length of 1.4 and the weight of 95 Newton. The student applies a force F to the handle perpendicular to the rail. The piston applies a force of 160 Newton to the rail. The diagram shows these forces acting on the rail. Determine the minimum value of F needed to lift the rail off, lift the end of the rail off the ground. Okay, there's a good question. It has to be uh, solved carefully. So rather making the tilted stand, I would like to prefer make it a horizontal one and redraw the forces like that. So the first one is at 90 degree. Okay. Well, for this one, I'll show you something what I'm going to do with it. So just hold on. Yeah. Okay. So now the force here is actually at 18 Newton. So this is 160, 18. This is 0.37 meters. This is my pivot point. And this is the point where weight is acting. Okay, 25 newtons. So if you remember that whatever the angle here is exactly the angle here, remember? So if I say that this is the weight acting down, so you can say that this is the, let me redraw it to perfection. Yeah, I think it's better. It's 90 and this is 42 as well. Okay. So I would say that the weight is now acting like this much. It's W cos theta. Okay. And it is at 90 degree to the moment arms or the beam. Okay. So this is force, this is 95 newtons, and this these are the like components. So this is not 95 newton only, it's rather 95 cos 42. I will just let you know why I'm taking that. So remember the rules to solve these kind of questions. Remember these rules, okay? The first one is F and R must be perpendicular to each other. And if not, resolve either R or F into its cos theta and sin theta components, and use that component which is perpendicular to F or R. So you understand? So F and R must be perpendicular to each other. This is the key that you need to remember. Now here, if you take a look in the given diagram, if you see weight and the beam is actually my moment distance, right? So the distance from the pivot is actually measured from the pivot, right? So here, so you can see that this whole length is about 1.4 and halfway it's 0.7, just halfway, okay? And this halfway also 0.7 meters. And you can see that this force is not perpendicular to the distance from the pivot, right? So the distance from the pivot is R, and here the force is acting like that. So what should I do with it? I have to go down and resolve this 160 Newton into two components. Now this will be 160 cos 18 and this will be 160 sine 18. So the rule was if the force and distance are not perpendicular to each other, you have to resolve either force or distance into two components. So here it is easy for me to resolve the force 160 Newton into two components. One is 160 cos 18 and one is 160 sine 18. Now you can easily see that those component of force 160 sine 18 is perpendicular to the beam or distance from the pivot, right? So you can write this force here as well, like this 160 sine 18. So that is at 90 degree. Now that makes a perfect um, pair to create a anti-clockwise movement, because you have to always rotate the force towards the pivot, okay, to see whether it is a clockwise or anti-clockwise. So first of all, get the 90 degree or perpendicular pair of distance and force, and then rotate the force towards the pivot to see whether it is clockwise and anti-clockwise. So here it is anti-clockwise, obviously, okay. Now whatever weight, if you see the weight is going this way, right? It's a clockwise thing. And why is it 95 cos 42? Again, you can see that the weight is not at 90 degree to the distance. So the distance here is actually, for the weight, the distance is 0.7 meters. And the weight and distance are not at perpendicular 90 degree to each other. I can see it. Obviously, it's not 90 degree. 90 degree means they have to be like this. If you see here, weight 95 Newton itself is not at 90 degree, but its component W cos theta definitely at 90 degree to the distance. Therefore, I am choosing 95 cos 42 here as the component of the weight, because whatever the angle here, you need to transfer this angle here. So now this pair is also at 90 degree to the distance, which is 0.7. Okay, and it is making a clockwise pair. And finally, the final force is already at 90 degrees, so you don't need to be taking much of the worry about that. So you just write it as it is, because that force is right away at 1.4 meters away from the pivot. So this force F is also be moved towards the pivot, and it is creating an anti-clockwise moment. Okay, now you have three moments. Two are the anti-clockwise and one is the clockwise. So you just write sum of anti-clockwise moments are equal to clockwise moments. Okay, so first one is 0.37 into 160 sine 18. Okay, plus then the second one for the weight, it's 0.7 into 95 cos 42 equals, for the third one, which is force, it's 1.040 times F. Okay, when you dissolve that into the components, you get the answer as 22.2 newtons and round it off to 22 newtons. Okay, the student could have lifted the rail by applying a vertical upward force to the handle. The force needed to lift the rail is different when the force is vertical compared with when the force is perpendicular to the rail. Okay, so what it actually saying that this is okay. So they are saying actually this force is actually at perpendicular currently, and if you apply this force like this to lift the handle or this way, what will happen? So this is the question. Okay, so you're not applying this force perpendicular to the distance, rather you're applying at some angle. So they're asking you, the force needed to lift the rail is different. It's different when the force is vertical compared with when the force is perpendicular to the rail. What does it mean? It means now you're applying the force perpendicular. Okay, like this. Before it was perpendicular to the rail, not perpendicular itself. Okay, so this is like now the new position, and this was like the old position. So now they're saying, what will be the effect when you do this? Okay, you have to say previously it was like this, but now it has applied this way. So that means you are I mean you are dissolving the force into two components, right? So if this is F, this is going to be F cos theta, and this is going to be F sine theta. Okay, if I take the theta to be here. Okay, yeah, so you can take any of the angle. Okay, So if I take the theta to be here, so it will be f sine theta and it will be f cos theta. So because f is having two components, one is f sine theta and one is f cos theta, and when you add them you get f, right? So for example, if this is 3 and this is 2, you get f to be 5, correct? So now you were applying previously 5 together, but now you are just applying one of the component here. So you are just applying one force. So what you need to write, when you take only the vertical component, you will just write as f sine theta is now acting to lift the rail, okay? Previously it was full F. So of course F sine theta is less than F, right? So in order to balance the clockwise moment, because now when this happens, the sum of moments, I mean the clockwise is no more equal to anti-clockwise. So okay, in order to balance, and this happens, so you say that the clockwise moment is not equal to the anti-clockwise moment now. And you just say in order to balance, the moments, what you need to do, you need to increase the force. Okay. Oh, we needed to have calculations as well in this. So okay, let me do some calculations then as well. Oh, my apology. It is written not need to do calculations. So no calculations are needed. Okay. So finally, yeah, that's right. Let me check the mark scheme. So they're saying yeah, okay. So that is something that I've written because you are taking the vertical component. Because of that, your force or your moment will become less, right? Because of sine theta is less than the f. So because of that, you need to have a greater force to be applied. Okay. So I think this is the answer to the question. Well, third point, I can write that hmm, to be increased. So this point is actually point number 3. A skydiver jumped from an aeroplane. The initial vertical velocity of the skydiver was 0. Okay, u was 0. During the first 1.5 seconds, the skydiver moved a vertical distance of 11 meters. air resistance may be considered negligible, so no need to consider the drag. I mean, yeah, of course. If the mean acceleration of the skydiver is greater than 0.95 g, deduce whether the air resistance acting on the skydiver was negligible during the first 1.5 seconds. Very easy question. So you just need to calculate the gravitational acceleration. Okay, and if it's turning out to be exactly like 9.8, okay, then it means the air resistance was negligible simply. So it is a free fall case. Again, it is a free fall case. So when it is a free fall case, I have told you that it is always second suvat that come into play. Initial velocity is 0, so this term goes to 0. And from here, the gravitational acceleration is 2s over t squared. This is what we need to find. So 2 into 11 divided by 1.5 square, and it is giving you the value of 9.78, okay, which is actually greater than 0.99 g, not 95. So air resistance is negligible. They mention if your value is 95% of the original g, then the air resistance is not negligible. But if it is greater than the 95% of the g, so it is the air resistance negligible. So you say air resistance is negligible. Okay. P part. The displacement time graph for the skydiver between jumping from the aeroplane and opening his parachute is shown. Okay, that's right. Sketch the velocity time graph on the axis below for the skydiver between jumping from the aeroplane and opening his parachute. Okay, so when he jumps, what happens? So, for example, this is the parachuter. Okay, initially its speed is 0 and the drag force is also 0. Why? Because the drag force is actually 6 pi r eta v, right? And drag force is directly proportional to speed. So when the speed is 0, the drag is also 0. Okay, okay. So therefore I'm writing at d as drag to be 0. But as you jumped and you start moving, your speed is increasing, right? So when your speed is increasing, there is a drag acting on you, and there is a weight acting on downwards, and there is an upthrust as well. Okay, but as soon as you are gaining more and more and more speed, the drag is keep on rising, but the weight and the upthrust are not changing. Okay, they are same. A moment will come when the upthrust plus drag will become equal to weight. So at this instant, the body will obtain terminal velocity. And that velocity is always maximum. Okay, so that is the instant when drag plus upthrust together become successful in cancelling out the weight. So when all the forces acting on the object become 0, the object moves at the terminal speed. Okay, so at here d was 0, but at 1 d was 0, but not at 2 and not at 3. At 2 it was rising, and at 3 it's rise even more. Why? Because the speed is increasing as you're going down. So when you reach the terminal velocity, what happens? Your speed does not change anymore. So you say my speed is rising, 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 and after that my speed becomes constant. Okay, so this is for 2 and 3. At 3 all the forces become 0, so your speed becomes constant. Okay, but since you are shooting, you're jumping from the airplane downwards, so it is like a analogy in the A levels that we always show the graph for the objects which are coming down in the negative side. Okay, so you need to just see what will be your speed, and you can get the speed through the gradient of this graph. So the gradient of the graph you can easily take for any of the values. Okay, so for example, if I'm taking the gradient for this point and this point, so I've just calculated the gradient, and the gradient is about 45 meter per second. Okay, so you just write like here 45 because the speed is negative. So you just write this. Okay, it's very, very simple. Okay, and the body is coming back to like a constant gradient graph from this point. So you may start to have it like from uh, this point, 7.5 or 10, whatever. Okay, so I would say that since I'm taking 10, so let's take the graph to the vertical position from 10 like this. Okay, so from here it's going straight. So this region is showing the terminal speed. Okay, and this region is showing 1, this region is showing 2, and this region is showing 2, and this region is showing 3, as I have written up. Okay, so the last part of this question is, after jumping from the aeroplane, the skydiver accelerated and then reached a terminal velocity before opening his parachute. Explain how energy conservation applies to the skydiver before opening his parachute. So just write 4 points. Initially, at start, GPE is max because he didn't jump in the start before jumping. GPE is max and KE is 0 because you are not moving. Then just after jump, GPE starts to decrease and KE starts to increase. Then as V increases, kinetic energy also increases, gravitational potential energy decreases. And finally, at terminal speed, Kinetic energy is constant. Why? Because kinetic energy is half v square only depending on speed. And when the speed is constant, your kinetic energy is also constant. Okay. So finally, who is working against the air resistance or something? So GPE is being used in doing work against the air resistance. Okay. So that is the end of your. Oh, we have the D part as well. Oh, 5 marker. The skydiver opened his parachute and his speed changed. After a time, he reached a terminal velocity. Okay. The skydiver opened his parachute and his speed changed. After a time, he reached a terminal velocity again. Explain how the forces on the skydiver caused his acceleration to vary after his parachute opened. Okay. So here is the answer that I have written. Okay. As you were moving down, okay, I'm saying as you were moving down with a terminal velocity, what was the equation suitable or valid for that? I said upthrust plus drag was equal to the weight, correct? But when you open the parachute, what happens? You see here, so many layers of the air are acting on you, so the drag is altogether increased. So when drag is increased, now you say that the sum of upthrust plus drag is no more equal to the weight. Okay. You say it's no more equal to the weight, rather it is greater than weight. So you say that these two are like upward forces, correct? and this is the downward force. So you say that the upward force is increased while the downward force is still constant because the weight is constant. So because of the upward force is increased, the body starts to decelerate. Okay. So initially, when you open the parachute, the balance of D plus UT is disturbed and D plus UT becomes greater than weight. And because of that, body starts to decelerate, or the parachuter. And when the parachuter is decelerating, the speed is reducing. And again, the speed and drag are directly associated with this formula. So when your speed is down, your drag is down too. So when your drag is going down, the moment will come and the D plus upthrust will become again equal to each other, and the body will gain back the terminal velocity. But now this velocity is smaller than the previous terminal velocity. Okay, but both are actually terminal velocities. So that is the end of unit 1. I hope you understand that well. I tried to explain in a very detailed way just to make sure everyone understand it in a very well way. Wish you all the best for your exam, and if you have any questions, any problems, or any one wants to have private lessons with me, you can reach me out on the given numbers on the screen. I wish you good luck for your exam next week. Wish you all the best. Thank you so much. See you in the next video. Bye bye.